Great to have you back. We've been going over databases for quite some time now, and one of the last things we had spoken about is uh, a, a structured database, a relational database, and a networked database. And right ahead, we had gone on to also speak about what a parallel database is and what a distributed database is. Now, not every database is the same. Sometimes when we try to set up a database, store data, we may set it up in a way that's logically incorrect. And that will then further complicate things for us, especially if we set it up in a way that's opposing the logic behind what we're trying to do. So it's great and important for us to understand what the concepts are and be able to conceptualize how we plan to store our data correctly. What is the difference between a database that is parallel and a database that is distributed? Parallel database is a database that has data stored in one unit, or let's say on one server. When we say it's parallel, because person A, person B, person C can all request for data and send data packets to the server without having to all sit on one computer. So computer A speaks to the server and receives his instructions back without interfering with what computer C has said to the database and received back. So that's why we use the word parallel there. Their data packets never intercept. They have parallel communication lines. Okay, so this type of database is very important because in this case, we can have, I'll use BVAS as an example. You can have all Nigerians send their votes to one server, the INEC server, and that server can have all of the data for all the Nigerians, and then that can be published on as many computers as possible. This, however, has some issues because having a single server means that when that server has an issue, the whole system will fail. Okay, take a look at this other example. We have a parallel database allows an online retailer to have thousands of requests like Jumia. Jumia uses a single server. So once you go to jumia.com.ng, you will request from the same server as someone living in Lagos. And that's great because due to its parallelability, all of your requests can be managed and handled without having any confusion. Okay, so now about distributed databases. I like to keep my example. I remember the example I gave you was in a distributed database system, we usually will have several servers. For example, LiveCamp, NGIS LiveCamp can have a single server for all of its students. NGIS Jabi can have a server for its students as well. And now in the process of storing data or retrieving data, the school's admin can choose to integrate both servers as one server. But then this is great because 300 and something students will be assigned one server and another 200 and something students are assigned to a secondary server or a different server. And this is very good because at the end of the day, you can always still connect both servers together to join as one server. But because you don't have all of the data in one central base, we refer to this type of setup as a distributed database. Also, if the LiveCamp server fails, you would notice you'll be happy because you still have your Jabi server functional and 100%. Now, this is great because you can avoid the total downtime of your organization. Also, you can be sure that your data is consistent because you can always pull up secondary school students' data from one server without having to do a lot of querying from the main database, which includes a lot of records that will not be useful to you at that point. Also, if you're trying to make changes, say change the class names to blue instead of gold, doing that on the server that concerns LiveCamp, the secondary section only, will be great, because having to implement that on a single database will be more cumbersome and then require more work. So those are some of the factors you may want to consider when you're creating a database. In the architecture of both database types, there are some differences. For example, in the parallel database, we have that a client and a server share nothing, or all clients share disk, which is where they store files, or all clients share memory. So there's a shared nothing architecture, there's a shared memory architecture, and there's a shared disk architecture. For the distributed database, we have the client server. That is, the client is speaking to the server. In the second, we have the collaborating server. In this type of architecture, when the client requests for some information, let's say the client is requesting for some information from, let's say, Google, then Google's several servers across the country or across the continent would work together. Who is the richest man in Africa? It to check all of the Google servers, Google Angola, Google Zimbabwe, check all the people's net worths, then work together. They collaborate to bring up one answer, and answer could be from any of the servers, and I could be at any of these servers requesting for this. But the main idea is that all of these servers work together or collaborated to get me my answer. Okay, in the case of the middleware acts as a middleman. So because it is not the central server, it is also distributed, because that way you can ask the middleware for some information and the middleware then goes to the right place to get that information for you. So these are the three main types of or architectures for both parallel databases and distributed databases. For parallel, we have shared nothing, shared disk, shared memory with the server and other clients on the same server. And for the distributed databases, which consists of several servers, we have the client speaking to the server that it is under. We have servers collaborating. Then we have the middleware server, which is intentionally being a middleman for the clients. Okay, so just like we had when we spoke about types of databases, it depends on what you want to build. If your concept or your logic requires a certain type of architecture, it's very important for you to know the downsides and the upsides of that type of architecture before you even go forward. For example, in parallel databases, we are seeing a situation where it is a good data warehouse. All of your data is in one place. And it's good because your organization will have all of its intelligence in one place. In the distributed database, we have where it is very scalable because one server attends to just a particular set of people. But also we should consider cost, because this will mean that you will require several servers to work, and then this will then increase the cost or money is being spent on your setup. Okay, it's good to know that we all know the differences between parallel and distributed databases. And also we know the advantages and disadvantages of each, and also the several different architectures of parallel databases, as well as architectures for distributed databases. See you next time.